Hello, hope you guys are doing well. So today let's get started with the LeetCode problem of the day. Its number is 3558 and number of ways to assign edge weights 1. So let's first read our problem statement and then we'll move to its solution. There is an undirected tree. We will be given with a tree. Like this is how my tree is. It's like undirected acyclic graph. Undirected tree with n nodes labeled from 1 to n. Rooted at node 1. Node 1 will be my root. The tree is represented by a 2D integer array edges. Like the tree will be represented by 2D integer array. Like edge at 0th index represents what? 1 and 2. There is a path between 1 and 2 undirected. Where edges I 2D array edges of length n minus 1, where edges I equal to ui comma vi indicates that there is an edge between node u and v. Initially, all edges have a weight 0. You must assign each edge a weight of either 1 or 2. Initially, each of my edge will have weight 0. So we are asked to assign a weight of either 1 or 0. The cost of a path between any two nodes u and v is the total weight of all the edges in the path connected net. Let's say between 1 to 4, its weight is 1, 1. So my total weight will be what? 2. Just need to sum them up. Select any one node x at the maximum depth. We are supposed to select any node at the maximum depth. So at the maximum depth, our node is 4, our node is 5. So we can choose any one of them. Now select any one node at the return the number of ways to assign edge weights in the path from node 1 to x. Like we are asked to find the number of ways to assign edge weight in the path from node 1 to x such that its total cost is odd. So let's first have some idea. So initially I'll be given with this tree 1, 2, 3, 4, 5, 6, 7. I think it's clear. So this is my tree that will be given to me. The very first step that we'll do, find the node at the maximum depth. So 6 and 7 is the are the nodes that exist at the maximum depth. So I'll find the first maximum depth in a tree. Maximum depth in a tree. So what is the maximum depth? 1, 2, 3. So it will be 3. Now, what are the total possible ways of assigning the weight to every node? Like I can either give 1, 2, 1, 2, 1, 2. It's 2 raised to the total ways. Total ways to assign weights are what? I can either assign 1 or 2. So it will be 2 raised to the power 8. So total ways will be 8. Now there is a trick. What is that trick? Like 8 ways. 8 ways. It's it's edge 1, edge 2, edge 3. I can either assign weight 1 or 2, right? So it's kind of a mm, hmm. Let's take let's map 1 as 0 and 2 as 1. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Now 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Right? This is how my distribution will look like. 0 is simply 1 and 1 is what? 2. So I can either assign 0, 1. So this is how my weight distribution will look like. Now, in how many nodes do we have with the 1? It's half. Like I have 4 nodes with weight odd because 1 contributes to 0 contributes to what? Odd. 0 contributes to odd. So these are for odd. Odd, even, its sum will be odd, its sum will be even, its sum will be odd, its sum will be even because last bit contributes to the sum. Last bit contributes to the sum. It's odd, it's even, it's odd, it's even, it's odd, it's even, it's odd, it's even. Because initially we are just swapping our bits. How can I say so? One will be odd, one will be even. That's a question. That's a question. Because I can either have odd or even. I can either have odd or even. So one will be odd because there is one difference. So either it will be odd or even. So this is how you can assume. Either of them will be odd, either of them will be even. So how many odds? We are asked to do what? Return the number of ways to assign edge weight in a path from node such that the total cost is odd. So odd is what? Half only. So total ways are 8. 8 by 2 is what? 8 by 2 is 4. So it's basically max depth minus 1. This is how what my answer will look like. So let's write the code for this, algorithm for this. Initially I will be given with edge, int edge. Is that clear? Now I'll create a graph, list of integer of my graph equal to new array list. How many? Let's say if I have a array of length 1, so I'll have two two edges, two nodes. So how many nodes will I have? Int nodes will be what? Edges dot length plus 1. So I'll initialize my adjacency list. Int I equal to 0, I less than or equal to node. Why we are doing I less than or equal to node? Because we have one based indexing. So graph dot add what? New array list. Once it is done, I'll do what? I'll do nothing, just create your graph. Int k edges. Now graph dot get k0 dot add k1. This is from node k0 to k1. There is a because it is undirected, so we have to add in both direction. K1 dot add k0. Is that clear? Now my graph is completed. Now I'll do what? Find the maximum depth. Int maximum depth equal to what? Get depth and pass what? Pass your graph, then along with the current node is what? I'll start from 1, and because whenever I'm like doing depth first search, I don't want to revisit my parent node. So I'll just consider 0 its parent. I'll only visit in the lower direction, because let's say if it is 3 neighbors are what? 1, 4, 5. I don't want to visit its parent. So I'll drop this. So I'll add what? Parent as well here. So one parent is 0. Let's say it's 0. I'm assuming it's arbitrary. However, 0 is not the parent of 1. So once it is done, I'll do what? Just create your answer, long answer equal to 1. I want to do what? 2 raised to the power max depth minus 1. So for int I equal to 1, I less than what? Max depth I plus plus. I'll do what? I'll do answer equal to answer into 2, and then mod 10 is to the power 9 plus 7, and then finally I'll return what? Return int of answer. Now I want to write this definition of this function get depth, so I'll write the definition as well. So private int get depth, so it's graph along with node and along with parent. So once it is done, I'll do what? First create max depth. Max depth equal to what? 0 or 1. Max depth is what? 0. Yeah, it's 0 initially. Let's say I don't have, I'll be given with an empty graph, so its initial depth will be 0. So for int I'll do what? Graph dot get node. I'll visit all of its neighbor. If I equal parent, do what? Do nothing. Continue. Otherwise, maximize your answer. Max depth and recursively call what? Max of max depth, comma what? Get, call the very same function depth, and then pass the graph, comma what? I, comma node, and plus 1 because I'm considering it also. Once it is done, I'll do what? Return max depth. So let's write the code for this. So initially I'll create my list of integer graph equal to new array list. So this is my graph. How many nodes are there? Equal to edges dot length plus 1. Now it is done. I'll initialize my adjacency graph. For int, I'll do what? I equal to 0, I less than or equal to node I plus plus. Now I'll do what? Graph dot add new array list. Now create the graph. Create the graph. Once my graph is 4, int edge, 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 and then edges. Right now, graph dot add get, graph dot get k0 because it's undirected, so I'll add in both the direction. K1 graph dot add k1 dot add k0. Now my graph is created. Int depth, this is my maximum depth, equal to get depth, and your graph you are going to pass your node is going to be 1, and your parent is going to be arbitrary parent is going to be 1. Now long answer equal to 1 for int I equal to 1, I less than depth I plus plus answer equal to answer into 2 mod 10 is per 9 7 1 2 3 4 5 6 7 8 9 plus 7. So return answer. Now function to get the maximum depth. Private get depth, and then my list of integer, and this is my graph, this is my node int node, this is my parent int parent. Now it is done. So I'll do what? Int depth equal to 0. Now I did for all its neighbor. Int I equal to graph dot get what? Node. If I equal parent, just do nothing, continue, because this is the parent node. I don't want to iterate over again. Now do what? Depth equal to max dot math dot max depth comma 1 plus get depth. Call the very same function to get the maximum depth for its child. Node will be I and its parent will be node. And then finally return what? Return depth. What will be its return type? Int. Anything else that you think? K1. Cannot find symbol K1 because it's edge. EDG. So K, K, and K. EDG. Anything else? Get, it's get, bro. And typecast it because we have created it long. and it's expected us to get int. So I'll do what? Typecast it. Yeah, let's submit this. So let's see. Yeah, it got submitted. So what is the time complexity of this? Since we are iterating over every edge, so it's big of edges, and then we are getting the depth. It's depth first search, so we are like plus maximum depth big of edges only, big of nodes, because that's the maximum depth we can have, big of nodes. And then we are doing, again we are doing max depth -1, so it's big of max, whichever the max, that will be my time complexity. So this is my time complexity, and space complexity will be what? It's big of edges into big of like total number of nodes into 2, edges into 2. So that's all from my side. Thank you. And if you guys have any doubt, feel free to ask. Just comment out. I'll be there to help you out. Thank you. Bye bye.